So what we learned from the mid exam until the last section, it was related to the text summarization, and then you learn about the deep learning, and you learn about basic transformer. This is about the attention and the Fritzen model and the transforming. Okay. About the text summarization, do you still remember? When we do the text summarization, it means we have some possibility whether it is single document or whether it is multiple document. If it is single document, then yeah, we have a one document, and it will produce maybe abstract, outline, or headline. If it is multiple documents, then maybe we want to create a series of news stories, or we want to have some topics or questions. And also we learn from the text summarization, we can get the extractive summarization. Extractive means we have some sources and we want to capture the key information is on the existing text. But the other summarization, we call it abstractive. So if it is abstractive means it is to generate new text. So we have a new text and it encapsulates the key information from the source text. So this is one of the research about text summarization. So if you have interest on this topic, or if you have interest on this domain, you can check. Based on the input, we can have type of document, whether it is single document or multiple document. And based on the nature of the output summary, you can have the two distinction, whether it is generic or it is query based. If you want to look at the algorithm, yeah, it depends on the algorithm whether it is supervised or unsupervised. If you want to look at the summary content, so we can see whether it is indicative or informative. So indicative means you can make something like outline, or you can indicate something. Okay, this is important. This is important. This is important. Informative, usually we have text like this one, and then yeah, we can point out the most important words in the text. So we have the summarization domain, whether it is general or it is domain specific. General means any kind of document, maybe from a novel, or maybe it is from the newspaper. So anything from the newspaper will be summarized. But if it is domain specific, so maybe it is related to sports, or maybe it is related to economic. So it is very specific. We call it this is domain specific. For the approaches, we can see there are several kind of approaches. For example, yeah, you know the extractive, you know the abstractive, and actually we can also use hybrid. Hybrid means the combination between two. And then we have the monolingual. Monolingual means you want to extract or you want to summarize your stories based on only one language. But nowadays there are many text summarization where it is multilingual. So you want to summarize the English, but you want to summarize it to the Korean people. So it means you will summarize the English, and then some of the explanation will be in Korean. So it is the multilingual or cross-lingual. So cross-lingual means when you want to summarize a paper, let's say notebook. You have one paper and then you want to summarize the paper and then you want to write the summary in Korean. Then it is cross-lingual. If it is based on the summary type, so you can check whether it is the headline. So headline means the title. You know, in the news we have the title. And then if you want to summarize this on the sentence, or if you want to make an highlight, or you want to make a full summary. So this is usually we call it as an abstract. Yeah, so there are many types of the text summarization. And based on the approach, so I just want to share this one. If you have interest on this text summarization, it is good. For example, if you do the extractive, so last time one of the method that we learned is the statistical base. So we check the score, and then after we know the score, then we extract that one. So we say that the sentence has the highest score. So it is the representative score as the summary. There might be another method. So like the concept based, topic based, sentence centrality, graph based, semantic based. Yeah, it is just the alternative. So we learn only the simple method, which is the statistical base. The abstractive. So you also learn from your assignment how to make the abstractive, but I don't give you any example of this one because it is very complicated for the manual calculation. So you can use some of the rules. For example, we can use the structure base or graph base, decision tree base, or we can use the rule base, template base, or something related with the ontology. Of course, we can use the deep learning to create what is the best abstract. So in the middle, there is hybrid. It means it is the combination of extractive and abstractive. So we can say from the extractive to abstractive. So we first extract something and then we generate a new text. Or from the extractive, we want to create a shallow abstractive. So shallow abstractive means we still have the abstract, but it will be more abstract. So you learn about the metrics. I hope that you can review again the metrics, how to calculate the metrics. So we have the BLEU, which is bilingual evaluation understudy. And then we have recall oriented understudy for existing evaluation. Rough. In the rough, we have several variants. Okay, we have rough one. We have rough two. And then we have different kind of rough. Meteor. It is metric for evaluation of translation with explicit order. Okay, so we learn those things. So please review this one. Then there will be one problem about this one. So if you have interest on the text summarization, I give you one link in the papers with code. You can look at the abstractive text summarization. And this is the model that people already use. And if you look at the result, using this data set, there are this is the best model until now. And if you do this one, you can see there are many data sets that you can use for the analysis. For the extractive, maybe it is not that popular because extractive is just to find one or two sentences, one or two important sentences. So the most representative model is the BERT with the RL. RL means the reinforcement learning. The next is about deep learning. So if you still remember, the deep learning, the basic of deep learning is using the recurrent neural network, and then based on node, we can go to the next node, we can go to the next node, we can go to the next node, and we can use the same width, or we reuse the same width matrix at every time step. So we will update only the it's, and then we use the same width whenever there is a new input. Whenever there is a new input. So you also learn last time in the learning check. There are some questions also for this one. Whether it is one to one, one to many, many to one, many to many, many to many, where the text will appear at first, and then the output will go to the next after we learn on some of the layers. But we can also do at the same time for many to many. And we also learn about the back propagation through the time. If we learn about the back propagation through the time, it means whenever we have one calculation or when we have one layer, we can directly calculate the loss. When we do one calculation on this layer, we can calculate the loss. However, we can also do with the truncated back propagation through time. What does it mean? So we just do the back propagation at the earliest time. So we run forward and backward through chunks of the sequence instead of the whole sequence. And then after we finish this one, then we go to the next sequence time. And then we go to the next time sequence. So because this is truncated back propagation through time. The layer will be truncated. Truncated means it will be cut. And then it will be cut again here. And then it will be cut again here. So because this is the truncated back propagation through time. Basic transformer. So in the basic transformer, we know that the attention is the key point of the transformer. For the key point of the transformer, we can have attention. So attention is a mapping of query and a set of key value pairs to an output. So where the query, keys, values, and output are all factors. So factors means any value. It can be a matrix. It can be only a single value, and so on. So the output is computed with a weighted sum of the values. So weighted sum, it means we have weight and then we do the summation. The weighted assigned to its value is computed by a compatibility function of the query with the corresponding key. So we will calculate the query and the respective key. So the query and the key value pairs are used in the newly proposed attention mechanism that is used in the graph mode. So this attention is basically has been used in the graph mode. I think you still remember we have one example. So the example here, we have three words. So we have Alice is kind. If you still remember, we can say the query vector for kind. Let's say it is 2. Okay. So 2 is just a number to represent that I want to find the word kind. And then we have the key vectors. So the key vectors is a number that has been represented. Maybe it is represented based on the embedding, or maybe it is represented by any factors created previously. So you have the Alice as 1, is 0.5, and kind is 2. So the value for the vectors, so we have Alice is 10, V is 20, and kind is 30. So if you still remember, we did this calculation. So first we calculate the query key similarity. So the query key similarity means I want to know the Q and the K. So we calculate by a multiplication. And then after we have this value, 2, 1, and 4, we calculate with the softmax function. So please bring your calculator, because you may need to calculate this one. After you have the softmax, so you will get the value, because Alice is 2 and is 1 and kind is 4. So we can get the value as this one. 7.39, 2.72, and then 54.60. So we call this is the softmax, okay, because we want to soften the value. So we want to normalize this value. We want to normalize this value. We want to normalize this value based on this E function. So the E function is, you can see 7.39, 2.72, 54.60. It is the summation. This is 64.71. And then we want to do the normalization. 7.39, which is this value, into the new numbers divided by the total numbers. So we have the Alice with this value for width, and is this value, and kind with this value. So the last one, we want to get the output, the attention output. So the attention output will be based on the softmax value multiplied by the V. The V, it is the V for Alice. This is the softmax value multiplied by the V of the is, and then this is the softmax value multiplied by the V of kind value. So at the end, we have this number, 27.27. Then this is the final output of attention. If we want to focus on the kind, then the value is 27.27. So I give also another example. Actually, when you do with the Q, K, and P, you cannot just do with single value. Usually it is a factor. What is factor? Usually we have something like this. So the Q is 1, 0, 1. The K is 1, 0, 1, 0, 1, 0, 1, 1, 1. And the V is something like this. 1, 2, 0, 3, 1, 1. Okay. So if you have this kind of matrix, what you need to do? First, the same with the previous one, you need to compute the similarity score. The similarity score means you need to multiply the Q and the K. Okay. On the previous example, when you calculate the Q and the K, you just do the simple multiplication because it is single value. It is single value. But when you do with the matrix, so we call this is the similarity score. It is the multiplication of the Q multiplied by the K transpose. K T. So the T means transpose. So if we do with the transpose, you have the value Q is 1, 0, 1. Okay, 1, 0, 1. Okay. And then this is the K transpose. So this is the K. And then this is the K transpose. The K transpose means, we want to get the transpose. So this is 1, 0, 1, 0, 1, 0, 1, 1, 1. So when you transpose this one, then the result will be 1, 0, 1, 0, 1, 0, 1, 1, 1. Okay, so this is the transpose. So this is the result. And then you will just do the multiplication. You know the multiplication? 1 multiplied by 1. 0 multiplied by 0. 1 multiplied by 1. Then you will get a new matrix which is 2. 1 multiplied by 0. 0 multiplied by 1. 1 multiplied by 0. Then you will get 0. 1 multiplied by 1. 0 multiplied by 1. And then 1 multiplied by 1. You will get the value 2. So this is the similarity score. After you have this one, you will do the softmax. So the softmax is using this formula. So we have the formula. We know this is 2, 0, and 2. Okay. So the X, we have the E2, okay, and then we have the E0, E power 0 and E power 2. Then you can have this is based on this value. E power 0 is 1 and E power 2. So let's suppose the E power of 2 is this one. Okay. So we can get the real value. We can get the real value 0.422, 0.057, and 0.422. After we have the softmax value, what will we do next is to multiply with V. So the multiplication with V means we have this value and we multiply with V. So the attention will be this one multiply with V. So the first column will be 0.42 multiplied by 1 multiplied by 0 and then multiply by 1. So you can get the value 0.844. The second column you will multiply this one with 2, this one with 3, and this one with 1. So you will get the value 1.7. So the attention score or the final attention score will be this one. Okay. So there will be one question about this attention score. Okay. If you understand the step is 3. So you need to calculate the simulation score, and then you calculate the submax, and then you calculate the final attention score. Next is about the pre-trained model. In the pre-trained model, you learn about BERT. So BERT is the bidirectional in-motor representation from transformer. So in the learning check, some of the students miss this definition. Please remember, BERT means the bidirectional encoder representation from transformer. So this is a kind of embedding. Okay. So this is a kind of embedding model. And if you look at the embedding models, there are several embedding models, whether it is context independent or context dependent. If it is context dependent, it means we have a model. Whether the model is based on the RNN, which is based on the decoder, or the model is based on the transformer. So this is the data set that they use for BERT. In the training data set, there are data set from book corpus, and it is 800 million words, and also from the Wikipedia. So there are 2,500 million words. So in this case, you can see there are so many data, and then the BERT has been used for the mass language modeling and the next sentence repetition. So we know about this one. So we already learned about the mass language model. It means if we have a text here, we have CLS, which is representing a class or a sentence, and then we have a mass. So it is something that we want to predict. By putting this sentence into BERT, then there will be a probability. What is the probability of this mass? So we call this is the mass language model, because we want to predict the mass word. So this is the mass word. If you get the 10% here, then it means this is the most possible word to be in this sentence. And BERT can be used also for the sentence prediction. So in the sentence prediction means if we have two sentences, so we can predict whether the second sentence of the input truly follow the first one. So the BERT will show you two classes. Is next and not next. Is next means it is truly follow. Not next means it is not follow. So if this one is the man blah 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 to the start. The second is penguin blah 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 are flightless birds. Of course, it is not correlated. Because it is not correlated, then the probability of not next is high. Okay, so because this is the sentence prediction. And we learn about the GPT. So GPT is the generative pre-trained transformer. So they have the transformer, and we use the transformer to pre-train, and it is to generate a new output sequence. And for the GPT, especially in the GPT-2, And the next, like GPT-3, GPT-4, they use the transformer decoders. There is no encoders. So in the GPT, or we call it the transformer, they said that there is no attention since there is no transformer encoder. So the transformer encoder, usually it is using the attention. So in the GPT, they use the self attention. So the difference between the self attention and us self attention. So do you know about this one? If we want to mask something, okay, mask means we put this is the text, so we mask it. So we assume that there is no word for this one. We call this is mask. Okay, we mask this one, and then based on this word, we want to generate what is the possible sentence, what is the possible sequence. So there are some only methods. The only methods they use the byte pair encoding, or we call it subwords, and also the new transformer with the self intention they use the positional embedding. So using the positional embedding, they claim that it is easy to fine tune to your design. So that's why this GPT is very common these days for the text generation. So the last one is about the transfer learning. Last week we learned about the transfer learning, and you learned there are some variants of the transfer learning. So whether it is the transductive transfer learning, domain adaptation, or the cross-lingual learning, and then the inductive transfer learning. So in the inductive transfer learning, we have multitask learning, or we have the sequential transfer learning. Domain adaptation. What is domain adaptation? It is on the different domain. So let's say there are many words about politics, but there are less words about art. Then I can use the word in politics. So I can utilize the words in the politics, and then I adapt those words to understand a new domain or another domain. So this domain will be adapted to a new domain. This is about art. So this is another domain. So we call this is domain adaptation. If it is cross-lingual learning, we know. If it is using Korean, I like rice. So it is English. And then I want to translate. So I want to transfer this one into Korean. Then, first you can say up, joy. Something like this. So it is the cross-lingual learning. The multitask learning, so we have several kind of tasks. Maybe the first task is text classification, or maybe the first task is task classification for the sentiment. And then the next is the task classification to check whether it is spam or not spam. So in the same sentences, in the same analysis, we can have several tests. So the first test is to check whether it is positive or neutral or negative on the sentiment. And the second test, I want to check whether this same input data, it is a spam or not spam. So we have the first task is sentiment analysis. The second task is spam or not spam. And you can also have another task based on the same input. So because this is the multitask learning. The sequential transfer learning. The sequential transfer learning means I think one of your team project uses this one. Let's say I have input and then I want to do the topic modeling. Because I do not know what is the topic of this text. After I know the topic, so I want to do the text classification. So you will transfer each of these tasks. After you do the topic modeling, so you transfer this one. After you do the text classification, you transfer this one. So it means this is the sequential transfer learning. So you will transfer this on each of the step in the text analysis. So in the transfer learning, we learn about the file, the full fine tuning. So everything or every weight in the model, let's say we use verb, so we transfer. We transfer it into the target domain. So we transfer everything. So because this is a source model, which is from the pre-train, so one can expect that it is a good feature extractor or parameter initialization. So to avoid overfitting, one can often freeze the layer or small target data set. So it can transfer to a different domain, but with the same architecture. So you learn about this full fine tuning, and you also learn about the knowledge distillation. The knowledge distillation means we have a big model, or we call it the teacher model, or we call it the source. And the teacher who has a high knowledge will transfer to the student model. And after they have their own model, they will check the output. So we also learn about this one. We learn with the KL divergence. Full delivery. This is the loss function. So we learn about the calculation. So please track the calculation. There might be also one problem for the knowledge distillation or the transforming. And the last one, we learn about the parameter efficient fine tuning, PEFT. So in the PEFT, what we learn is we just try to fine tune only the best parameter or only the suitable parameter. Okay. So updating only a specific set of parameters rather than adjusting all the model parameters. Why we need to focus on this specific set of parameters? Because it is to reduce the computational resources and it is to reduce the memory uses. When you do the full fine tuning, usually it takes long. So we can use the PEFT. So it means we will freeze. The word freeze means we will just close the existing parameters and only change the selected parts. So only change some parts. So we learn about LoRa, low rank adaptation, and the Q-LoRa, nice LoRa. Okay, I think that's all. Okay. So if you do the summary, please check also about the calculation. Okay, some of the calculation will be in the final session, and especially I will give you the problem about the tension that I just explained today. Okay.